Hello guys, how are you? Welcome to Cosmic Essence Education. My name is Maitray and in this video I'll be talking about arc length and sector area. So let's get started. Okay, so before coming to the formulas, let's look at the different parts of the circle of what an arc of a circle is or the sector of a circle is. So this is a circle with center at O and say radius is R. Now the different parts or different definitions in a circle. If I join any 2 points on the circle, then the line segment is known as a chord. Any 2 points on the circle are joined, the line segment is known as a chord. The chord divides the circle into 2 parts. This is one part and this is the second part. This part is known as the minor segment, as it is less than half of the circle, as it is a smaller one. This is a larger one, so this is known as the major segment. Now the part of the circle between 2 points, on its circumference is known as an arc. This is an arc. Now also you see that these 2 points divide the circle into 2 arcs. This is one arc and this is the second arc. So the smaller arc is known as the minor arc and the bigger arc, which is this one, this is known as the major arc. Now if I join the center to these end points of the arc, now a different part of the circle is formed, which is this one, and this complete part that is enclosed between 2 radius and the arc of the circle is known as the minor sector, and the part which is enclosed by the major arc and the 2 radius is known as the major sector. So after we have seen the different parts of the circle, we can now move forward to the formulas. Okay, so the length of the arc of a circle can be written in terms of the angle it subtends at the center and the radius of the circle. So let's see how. We have a circle, say of radius r, and length of arc is L. Now the length of the arc when angle subtended at center is 2 pi radians. That means 2 pi radians will be subtended by the circumference. So the length of the arc is 2 pi r. The length of the arc when angle subtended is 1 radian is equal to 2 pi r upon 2 pi, which is equal to r. The length of the arc when angle subtended is theta radians is equal to theta into r. That means length of the arc L is equal to theta into r when theta is in radians. So this gives us the formula of length of the arc in terms of the angle subtended by it at center and the radius of the circle. The same formula in when the angle is in degrees is theta by 360 into 2 pi r when theta is in degrees. This formula can be found by doing the same method here, or by converting this theta in radians 2 degrees, and we'll get this formula. Now, the second, the area of a sector. The area of a sector can also be written in terms of the angle subtended by it at the center and the radius of the circle. So, sector area. So, the area of sector when angle is 2 pi radians, that means the whole circle is a sector, the area will be pi r square. The area of sector when angle is 1 radian will be equal to pi r square upon 2 pi. Then the area of sector when angle is theta radians is equal to pi r square upon 2 pi into theta, which is equal to 1 by 2 theta r square. Therefore, the area of a sector is equal to 1 by 2 theta r square when theta is in radians. The same formula is equal to theta upon 360 into pi r square when theta is in degrees. Again, this formula can be got by the same method here, but instead of taking angle in radians, we'll take angle in theta, or by changing the angle here, which is in radians, to degrees to get the second formula. Okay. Now, another very important formula is writing the sector of area of a sector in terms of the length of the arc of that sector. So, we know that L is equal to theta into r, and area of sector is equal to 1 by 2 theta r square. If I substitute theta r is equal to L in this formula, I will get that area of the sector is equal to 1 by 2 into L into r. So this time the area sector is in terms of the length of the arc and the radius of the circle. So very important formula as well. So let's look at an example. Example is a sector has radius 12 centimeter and angle subtended at the center as 3 radians. Then find the arc length and the area of the sector. So first, arc length, which is L, is equal to theta r. Theta is given to be 3 and r is given to be 12. So we get length of the arc is equal to 36 centimeters. Area of this sector A is equal to half into theta into r square, as the angle is in radians. So this is equal to 1 by 2 into 3 into 12 square, which is equal to 1 by 2 into 3 into 144, that is 216 centimeters square. Okay guys, so we looked at the length of the arc and the area of a sector in terms of the angle subtended by it at the center and the radius of the circle in this video. I hope you liked the video. If you did, hit the like button and subscribe to our channel. We'll be bringing in more videos like these and we'll be covering the whole entire syllabus. So thank you.